So real quickly, the pre-acquisition team, we had 2 sysadmins, 2 software guys, myself included, making sure that the site scaled, 2 feature developers, 2 network engineers, 1 DBA, and unfortunately no chefs. And now we have 2 as well, so I guess the theme of 2 continues. Here's my little algorithm for handling rapid growth. You start by identifying and fixing bottlenecks. You drink the beverage of your choice. I'm not suggesting anything. Just drink the beverage of your choice. You sleep a little bit, and you notice something new, and you start all over again. That's how it is, I guess, with a rapidly growing site. One of the key phrases that we had in the early days was, "These are good problems to have." And after a while, we're like, "I'm going to kill the next person who says that."
Is that multi-threaded?
Well, that's a good segue to my next slide, because in this particular case, there's a little bit of drinking and sleeping going on there. This is one of our 2 sysadmins before the acquisitions. All right, so to move into some of the nuts and bolts here, we have web request flow. It starts with an end user, then the request flows from the user's browser to a set of NetScaler load balancers. From that, it goes to the web servers, and this is a bank of web servers in a YouTube colo. And these machines don't really maintain any local state. They're just like, one goes down, nothing really happens to the site. Within these machines, Apache receives the request from the NetScalers. It checks to see if it's a dynamic request. If it's a dynamic request, it'll forward the request on through FastCGI to a local app server, multi-process app server running on the same machine, which is written in Python, our programming language of choice for all the application code here. And that will, Python retrieves information from various places. It retrieves information from RPC, from our memcache servers, which store information retrieved from databases and other expensive, sort of relatively expensive data sources, and obviously our databases for things that either are uncacheable or are not in our caches. For video, we have 2 different places where video could come from. The first is our CDN. It's an internal project written by a group at Google, and that CDN takes care of a number of things. It basically takes care of the content that is most popular on the YouTube website. So sort of the mega hits and the things that are maybe not be necessarily a hit within the U.S., but a hit maybe in Europe. Let's say, for example, maybe some pretty interesting soccer videos, for example, which may be more popular in Europe. It takes care of serving up all those videos and make sure that there are multiple copies of the video for quality of service, reliability, and also ensures that a copy of the video is relatively close to the user, so they're not going over various network hops, like too many network hops and a transatlantic link to get to the video. And for the rest of our videos, they're hosted on at YouTube colos in various places in the U.S. At least for right now. We're considering other locations, but for now it's the U.S. Key technologies. We use Linux, specifically the SUSE distribution of Linux, various versions of in the 10.x line. We use Apache, as I mentioned just recently, for serving of content through the YouTube.com site, as well as, I think, the mobile site and some other things, and the API. And for video serving, we use Lighty, because it's just so much faster in handling large files. It just blows Apache away in terms of performance when dealing with large numbers of connections, a high connect rate, and large numbers of videos. Large file size, rather. MySQL is used for all the metadata storage, so some things like user information, like users, the username, hash version, the password, etc., that kind of thing. And finally, as I mentioned, Python, and it turns out that Python was actually a very good choice of programming languages for us, because, especially in the early days when it was very difficult for us to recruit people, especially when we were tiny. For a while, we didn't have a full-time recruiter. It was just far easier to put out a purchase order to get 10 machines versus getting 1 or 2 talented engineers to magically materialize and start and get ramped up in our system. So we traded off sort of time to market and developer efficiency for, for some other stuff, maybe slightly slower code, but code that's less susceptible to Stack Overflows and other nasty things that you might see in other programming languages. And finally, Google technologies. We use a number of things that you might have read about and seen. Obviously, search is one of the key ones. But aside from search, we use Bigtable internally for storing video thumbnails. We use GFS for a number of internal file storage needs. We use proto-buffers, which were recently open sourced. And just a number of Google technologies in general, and we're kind of scaling that out over time as we find specific problems that require massive computing power, require the distributed computing that the Google infrastructure affords us. For our databases, we started with one, and obviously, like Edie said, we started with one main one, and a replica for backup, and a replica for reporting, but we quickly outgrew that. We now have multiple vertical partitions, which are basically where when we take a part of the website that kind of stands on its own, and that part of the website doesn't have too many external dependencies. We took that and we stuck that part on a separate set of database machines and maybe even a separate set of web machines, and we said, okay, this can scale on its own. It doesn't have to bother like the rest of the site. And same thing with other parts. For parts of the site that were sufficiently large and that were hard to disentangle, like for example the user metadata and the associated video metadata, we did horizontal partitioning, where we split it up. Like we have multiple database instances with the same schema, but different sets of users. So one nth of our users are in this partition, one nth are here, one nth are here. And we did that just because that seemed to be the most scalable way to do it. And then we have a lookup database that allows us to associate a user with one of these partitions, so that common operations like watching a video and seeing a user channel page are much quicker than they would be otherwise if we had to scan through each of the databases. Those scalability challenges. We've had a number of major challenges. It seems like every time we add capacity, there's a number of things that can sap away the capacity. The first was rapid and unpredictable growth. It's pretty amazing, like as I mentioned before, when it seems like no matter how much capacity you add, the users come back and consume all of it. It's gratifying and it's rewarding, but at the same time, it's definitely a challenge because, especially in the early days, we didn't have the budget, pre-acquisition, and even post-acquisition. There's still only so much you can do when you build in a certain kind of buffer, and then the growth just eats through all that buffer and more. So it's an interesting game to play. Not having too many excess machines around, not spending too much money at one time versus trying to keep up with user growth. Passionate users. We couldn't have foreseen when we started the site that some users would have thousands and thousands and thousands of videos, and people would want to do video blocking like for every second of their life, things like that. And those are good uses of our site, but it just means that we need to work a little bit harder in some of these cases to make sure that we can accommodate these types of uses. New features. A couple years ago, the video space was kind of brand new, and you were lucky to be able to play a video without installing some kind of OS-specific plugin or whatever. But now there's definitely a higher baseline, right? I mean, not only do you need to have ubiquitous access to videos, embeddability, APIs, all this stuff is assumed. Now you get to stuff like recommendation algorithms and social graphs and all sorts of things that are not computationally cheap. So it's certainly a challenge to try to balance user experience, new features, and scalability of the site. Pushing hardware and software boundaries. I'll talk a little bit about this later on, but basically when you run hardware and software too close to its limits, it's more likely to fail. And I'll go into a couple of examples of times we run into these kinds of issues. And finally, the performance bottlenecks are getting very obscure. I mean, we filed bugs with a couple of the vendors that provide support for our open source software, because sometimes we want a little extra, few people to help look at some issues. And it turns out that when we forward those bugs to them, they're like, really? And then they spend a few days reproducing it, and they don't really have any kind of real solution for us. It's kind of interesting when you get to that level, and when you start Googling for stuff, and when you start searching blogs, and you don't find anything like about the problem that you're encountering. It definitely puts you in an interesting spot. And some of these problems can be solved by having more headroom, but for software and for some of the software stuff, we're pushing it in ways that I don't think the creators ever intended. So here's one example of an issue we had. If you can't read it, it says, we can't accept any more videos, too many videos. So this was sent at 2:24 a.m. on October 22nd. I was about to go to sleep at that point, and this wasn't a very pleasant email to get. And basically, our video uploads had ground to a halt. And after a little bit of debugging, it didn't take very long. We figured out that, well, we sort of did the original boneheaded, but let's get it out kind of like startup kind of mentality of putting storing the video thumbnails for each of our videos into separate subdirectories, but all the subdirectories were in one flat directory structure. So we had tens of thousands of files in one directory. Not a good idea. So we ran into an inodes per directory limit, at least on ext3, which was the file system we were using. Pretty bad thing, and it's not something like, it's obviously not rocket science that you should put too many files in a flat directory structure, but we were trying to keep up with growth, and it wasn't too hard to solve it, right? I mean, we went to like a tree structure, a hierarchical structure. It just wasn't the most pleasant thing to code at that time of night. That's all. And to test, and under the pressure of all the video uploads failing in the meantime. So it wasn't the funnest thing. Another thing was going back to the earlier comment I made about pushing things to the limits. We were pushing our database to its limits because we hadn't developed the infrastructure required to partition it yet. It's a difficult problem. So this email, or this posting, I should say, this article from CNET was covering our downtime that we had. It started at 7:30 a.m. and went for 5 hours. It was very unpleasant. I think even more unpleasant than the actual downtime was the fact that my parents were calling me, asking me if I was okay, and asking and trying to lend me their moral support. So I was like, I just need to deal with this. And we looked at the logs, and MySQL had given us an error. The error was that checksum had failed. And the reason, and what happens when MySQL reads data from the disk is that there is a checksum stored for every page, which is about 16K, I think. It's stored on disk, and then when MySQL reads the data from the disk, it calculates a new checksum and compares that against what's stored on disk to make sure that nothing in between the disk and the process is messed up, and the data is actually intact. Turns out that they didn't match, so MySQL kills itself at that point. And not only does it kill itself, it takes 4 or 5 hours, or depending on the volume of transactions and what the volume of changes that have not been flushed to disk, it will take 4 or 5 hours to recover. And at that point, a lot of us, we didn't have a dedicated DBA at that point, or he had just joined, he didn't know MySQL yet, and I was filling in for that. Anyway, we went through all sorts of stuff to try to figure out what the culprit was. We searched everyone online. We found a lot of questions, but no answers, no solutions to this issue. And we frantically put a whole bunch of orders out for different pieces of hardware that may not exhibit the same issues. We're thinking maybe it's a hardware issue because not everyone is having this, and lots of people use MySQL. Some of these people are bigger than us. And after a long period of time, we happened upon one blog post, exactly one blog post written that very day, saying that there is an issue with this little guy, which is sticking on with the expansion stuff. It's a riser card. Because we have recently, for performance purposes, switched from a 4U machine, which is taller, to a 3U machine, because the 3U machine could be outfitted with a faster I/O subsystem, at least for the vendor we were using. And the shorter shorter height meant that we couldn't accommodate a full height expansion card like the RAID controller that we had. So we had to put a riser card so that instead of going like this, the card goes like this, where there's plenty of room. And it turns out that the combination of the RAID card and the riser card would sometimes cause interesting fluctuations of voltages that might cause an inverted bit every now and then. So that's exactly what happened. The data was fine on the disk. We validated it after it crashed. It was fine. But somewhere between, somewhere reading the bits off the disk, something went wrong. But that was definitely a very tense 2 or 3 days, or weeks rather. And the next thing I'm going to mention is actually one of my favorite ones. So we were going to run out of disk space because we were having vendor issues, trying to get things in on time, and growth was just explosive. So we did the right thing, which is to order machines slightly early, and we said, oh, let's rush a shipment to us. The problem is that the shipment was rushed in the wrong way. It ended up, actually I don't even think this is where it originally was. I think it ended up on someone's BMW originally. It was unloaded unceremoniously in someone's car.